All right, for the last section of this chapter, of chapter 13, we're going to talk about factorial design. Most of what I'm talking about here would be independent measures or repeated measures. The key here is what we're talking about is having more than one factor. We know that everything we've been working with in terms of problems has been single factor. But as I indicated at the end of the previous video, having two or more factors is pretty darn common. So there's some basic vocabulary that we need to understand so that when you encounter this in the research, you can break it down and understand it, because otherwise it tends to be pretty dense. It's a lot of data and information packed into these studies in a fairly compact way. So the first thing we want to talk about is called design notation. There's a specific way that they tend to write these in their reports. What it is a series of numbers with symbols in between them, with X's for the word by. So let's pretend I am doing a factorial design, and I write in my paper that I am conducting a 2 by 3 factorial design. I would write that like this, 2 by 3. I could conduct a 2 by 2 by 4, a 2 by 3 by 2, a 3 by 2 by 6. So what do we do? How do we break this down? What do we say if we say it's a 2 by 3? The first thing you want to look at is how many numbers are written up there. The value of the numbers is irrelevant. So 2 by 3, there's 2 numbers there. What that tells us is how many factors there are. I see 2 numbers, that means there were 2 factors. If I add onto it here at the end, now I'm reporting I did a 2 by 3 by 2 design. I see 1, 2, 3 numbers. That tells me there's 3 factors. So every number up there represents a factor, a different factor, not different versions of that factor, a completely different factor. So let's back up to the first thing I wrote here, a 2 by 3. Well, this tells me that there's 2 separate treatments, 2 different factors, 2 different things I'm looking for to have an impact on the dependent variable. Well, this one might be your biological sex. That's one factor. How do males perform in some capacity versus biological females in some other capacity? And this one might refer to, I'm going to use the example I was using earlier, room temperature. Completely different independent variable, completely different factor. If I kept that times whatever by what I think I had a by 2 up there, then that could be something else, smoking status, or it could be college graduate, yes or no, or it could be whatever, high anxiety, low anxiety, whatever. So how many numbers you see tells you how many factors there are. The number itself, the value of the number itself tells you how many levels or attributes of that factor they're using. So this number here of a 2 is one factor with 2 versions. This number 3 is a different factor with 3 versions, 3 levels or attributes. So for example, obviously we would probably be looking again at biological males versus biological females. These would be my 2 versions of sex. Over here, room temperature. I might have us work in a room that's 50 degrees Fahrenheit, a room that's 70 degrees Fahrenheit, and a room that's 90 degrees Fahrenheit. There are 3 versions of temperature in this study. 3. So that's reading the notation. So sometimes they'll even, in parentheses behind the number in published research, tell you what the factor is. So they could have maybe written this, depending on the publisher, as a 2 sex by 3 temperature ANOVA, to help the reader figure it out. Now, whether this is independent measures or repeated measures doesn't matter in terms of the notation. It's the same. We know the difference is, are we using a different sample in each group, or are we recycling that same sample of folks through every condition? But think about, based on what we have here, we would need, if we were doing this as independent measures, different samples, we need a sample of males in a cold room, a second sample of males in a warm room, a third sample of males in the hot room, a sample of females in the cold room, females in the warm room, and then females in the hot room. We would need 6 different samples for that. That's a lot of extra work gathering those different samples. We did it as repeated measures. We would just put everybody through the same conditions, right? So all the males would go to each room. All the females would go to each room separately. So that's our design notation. Again, look for how many numbers there are. That tells you how many treatments or independent variables or factors there are. And then the value of it tells you how many levels or attributes of that factor they're using in the study. Now, in analyzing these types of studies, there's 2 levels of statistical analysis. One of the things we're looking for are called main effects. In fact, main effects is all we've been doing in these last 2 chapters. A main effect is statistically analyzing for the impact of a single factor on its own. So it's just looking at one factor. So if this was our study, there are 2 factors. That means there would be 2 main effects. We would want to know how biological sex impacts the dependent variable all by itself, whatever that dependent variable is. That's one main effect. And then forget about sex for a minute. Let's just look at room temperature. How does being cold, warm, or hot in the room impact performance on some dependent variable? If I had a 2x3x2 and the other one was whatever, again, let's say smoking status, smoker, non-smoker, well then we'd have a 3rd main effect. There's a main effect for every factor. Main effect for every treatment separately. So first let's just analyze this one and see how it goes. Next let's analyze this one and see how it goes. Then once we've looked at each factor individually, each factor separately, all on its own, then we can start doing interaction effects. Interaction effects are designed to look at combinations of variables simultaneously, how they interact with each other. So again, interaction effects. So now that we've done the main effects, now we want to look at every combination. Males in the cold room versus males in the warm room versus males in the hot room versus females in the cold room versus females in the warm room versus females in the hot room. So that's 6 interactions. So for this factorial design, there'd be 2 main effects to do. Imagine the ANOVAs you've already learned how to do. That's doing 2 of those. One for this factor, one for that factor. And then you have a whole bunch of additional math for each interaction. That's why I say it's just too much to do by hand. It's not that you guys aren't plenty smart enough to learn how to do it. It just is, it's really laborious. This is where you want computer software for sure. So let's look at just real quickly another possible example just to drive this point home, and then we're done with this chapter. So let's say a researcher says they are going to do a 2 by 2 by 3 design. Well, we have to start with what does it mean? How many numbers do I see? A 2 and a 2 and a 3. That tells me there are 3 factors. There are 3 independent variables. So, how many main effects would I have to analyze for? 3. Every factor gets analyzed on its own. So let's say we're checking against, I don't know, some kind of problem-solving skill. And this one, this factor is anxiety. This factor is age. And this factor is medication. 3 numbers, 3 different treatments. So how does having your anxiety status, how does that impact the outcome? Your age, how does that impact it? And your medications, how does that impact it? So there would be 3 main effects. What impact does anxiety all on its own have to do with the dependent variable without thinking about those at all? And then age as a main effect, and then meds as a main effect. Then we'd have to start looking at the interactions. Well, we're going to have to be a little bit more specific here. So anxiety, there's 2 versions of anxiety in this study. We're just going to say low anxiety and high anxiety as determined by some measure and some test. So we're either calling the people low anxiety or high anxiety. Age, well, I only put a number of 2 there. So let's say that you are either an adult, you're either a child or you are an adult. That's weird. I skipped adolescence, but whatever. I put a 2 up there. That's what it is. Hey, that's what it is. Third one, medications. Well, you're either taking 0 milligrams or you are taking 10 milligrams or you are taking, I'm going to make it 30 milligrams. Those are the 3 versions of the meds. Again, on what our dependent variable is, I said something about problem solving. So, interaction effects. Look at all the interactions that we would have to do here. Low anxiety children on no med. Low anxiety children on medium med. Low anxiety children on high med. High anxiety children on no meds. High anxiety children on mid meds. High anxiety children on high meds. Low anxiety adults on no meds. Low anxiety adults on 10 milligrams. Low anxiety adults on the high dose. High anxiety adults on no meds. High anxiety adults on 10 milligrams. High anxiety adults on 30 milligrams. You can see that mathematically that gets to be a real jungle of calculations. More to the point here, you reading research, it becomes a real jungle of a results section to wade through. But if you can look at those numbers and know what they're telling you, it makes all the rest of this so much easier to process. So that is looking at 2 or 3 or however many factors, factorial design ANOVAs, where we've got more than one factor at a time to deal with. So there it is, everybody. That concludes chapter 13 for us. We are done with ANOVAs. So our very last chapter for our final week of the course in correlation coefficients, you're going to find that chapter way more about vocabulary than math. It kind of harkens back to the days of chapter 1 in a lot of ways. Not much math, but a lot of vocab. So you might want to take a look into that when you get prepared for it. So there it is, everybody. Process this information, work on some homework, do your labs for this chapter when you get a chance to get to those, and get yourself ready for your quiz. As always, questions, thoughts, concerns, send me an email. Let me know what's going on, see if I can find a way to help you. Otherwise, I still continue to hope everyone's doing well and taking good care of yourselves. And I miss all your faces. And we will see you through the lens for our last chapter in just a little while. Bye.